Yes, thank you very much, Ilya, for this great introduction. And I'm very honored to give the last talk of this so far really awesome workshop that we have all seen today on the topic of open source, a catalyst for solving the generation problem. And we have heard this in many talks today, but actually this is like the biggest discussion in our community, I would say, at the moment, which is a discussion between two different paradigms in autonomous driving that we see so far. One is the modular approach, and one is the so-called end-to-end approach. And both of these paradigms actually emerged at around the same time. So the modular driving stack was first shown back in 1986 in Munich by the TUM group, whereas the end-to-end approach actually emerged just 2 years later at CMU with the Alvin, as many of you know. So fast forward 40 years, and looking at the current state of affairs, where the modular approach kind of like is the benchmark in autonomous driving if we consider commercial deployments. Most of the commercial deployments out of the world are based on a modular driving stack, whereas the end-to-end stack is more like a transition. A lot of companies are transitioning towards, or new companies emerge to take on this new end-to-end or this old new end-to-end approach. But in the end, and also for me, this is kind of like a trade-off. So what you're doing here is you're trading the efforts in algorithmic development against the efforts in data creation. So rather than employing 1,000 engineers to design and engineer the driving functions in software, you are now employing 1,000 test drivers and 1,000 data engineers to create your data sets. So the questions we asked is there a different paradigm? And we believe there is. So why not leveraging the efforts or the power of the open source in the large autonomous driving community rather than employing 1,000 engineers? And this is what we were taking on. So we deployed this third paradigm. And in order to do so, we built on a state-of-the-art autonomous research vehicle called EDGAR at TUM. The EDGAR vehicle serves as kind of the base research platform that we use and that we have equipped with the latest and greatest cutting edge technology in terms of sensors and compute and everything you want to wish for. And on this research platform, we then deployed one of the, or when, if not the most important and well-established open source driving stack, which is the Autoware driving stack. But not only have we based our technology in open source in the software stack side, but also on the overall framework side. So we use the great ROS2 framework. Everything is published open sourced. We also use the Kala simulator to actually pull this off, and then used the capabilities and the knowledge of our group to enhance and contribute to these open source frameworks. So we have extended the driving stack with our own implementations, with safety features, with teleoperation, with perception, prediction, planning features, and so on. But it's not just software. Actually, autonomous driving is a lot more than just the driving stack. And if you want to deploy in real world and drive, you need a functioning development chain. And this is what we also developed over the years with the help of a lot of PhDs. So in the very beginning, if you have a new sparking idea and want to solve a real-world problem, there is function development. But before you can really see it driving on the real vehicle, you're going through software in the loop unit test for the individual driving functions. You stick everything together in an overall integration test in our hardware in the loops environment. And therefore, we have also developed a digital twin that is actually also, all of this that I'm showing here is open sourced by our group. Before you can then really deploy this on a real-world test drive. But the most important part actually comes once you were out there in the real-world driving, because there you collect the data, there you experience all of the failure cases, to then record everything in a data center where we currently held about like 2 petabytes of driving data from all of our different deployments, and to then go back the chain. So develop and improve our digital twin, synthesize new scenarios from this data, come up with custom tests for our unit tests and actually identify still the shortcomings of the software to identify new problems that we can take on in research. And as I said, everything of this is put open source. And we are not just presenting this overall development driving, but we are actually living it. And we in our group think about it as a challenge. So we always set ourselves ever increasing challenges, ever more difficult challenges to actually push the state of the art and push what's currently possible. And the first challenge that we have taken on a few years back, so this is actually, I think, around 3 years back, was the so-called Wiesn Challenge. So many of you know, so we are from Munich, and Munich hosts one of the greatest, the largest Volksfest in the world, the so-called Oktoberfest. And we were asking ourselves a few years back, can we actually provide autonomous shuttles on the Oktoberfest in Munich? And therefore, we have chosen a round here right next to the Oktoberfest. So this is the main entrance of the Oktoberfest. 1 million people are walking from the main station and the U-Bahn to the fest site. And there we wanted to deploy our autonomous vehicle. So the challenges that we faced in the scenario were on the one side, we have narrow roads of a European city. We have really dense urban traffic, especially to the Oktoberfest time. We have really diverse traffic participants in all different senses. You encounter rickshaws, you encounter people wearing crazy hats and costumes attending the Oktoberfest. So this is really challenging. And especially crowds of intoxicated people that are not sticking to traffic rules whatsoever. So you cannot rely on any traffic rules in these environments. So the question is, can we provide autonomous driving to this challenge? And the answer is yes, we did so. And we did so back 3 years back, and we drove around with our EDGAR vehicle multiple days in a row, shuttled people to the Oktoberfest back and forth. This was a huge success, not just for us, but for the whole group, for the whole community. However, for me, the most important aspect and also the most important point that I want to make today is the learnings that we made by these deployments. So what did we learn? What are the remaining challenges that can also give you new ideas, new frontiers to take on in research? And the learnings that we had with the remaining challenges that still did not work after these deployments is the setup that we drove back then was a classical modular approach, which is reliant on a very good curated high definition map, and maintaining high map quality throughout the deployment is really challenging because, especially in this environment, the road changes from day to day. There are construction site, there are security policies applied, and so on. So you have to keep up with your HD map on a dynamic basis. Second of all, the detection of really rare object classes that are actually not contained in any of the open source data sets that we heard about so far. Like as I said before, for example, trams, rickshaws, and all of these people like wearing crazy costumes. This is really, really challenging for all of the perception algorithms. Next up, back at the days, actually jitter-free object tracking was a huge challenge for us. So if you have not a super perfect detection and tracking of the objects, you introduce artificial velocities into the objects and then get like false predictions. And especially in these super narrow roads with like very crowded environments, we were talking about like 1,000 agents around you, then it becomes super challenging ensuring that every of these agents is pinpointed by your perception stack. One very interesting also learning for us was, so we were aware that there are 1,000 people walking around us, and we actually developed custom algorithms, state-of-the-art algorithms for object detection and especially prediction for pedestrians that can actually scale to these number of agents for real-time deployment. However, the most challenging agents around us were not the pedestrians itself because they were rather slow moving, but fast moving VRUs, something like bicycles or e-scooters. They are super challenging to actually deal with. Next up, planning with super small safety margins. You have to keep distances of a few centimeters, maneuver through crowds of people in these environments. And if you do not do so, then you don't make any progress on the road. Last but not least, as I said, handling constant traffic violations, and also something that you only encounter if you really deploy an overall system, is these high intermodule dependencies between the perception, the tracking, the planning, back and forth localization, and so on, which is most of the time neglected in most of the research papers that we see. So with all of these learnings, we said ourselves, okay, what is the next challenge after this? What is the next challenge that we can take on? And this was something that we said, okay, we take the last year's IAA as a challenge for us to generalize this concept, all of these learnings that we have made, to a much larger ODD. So far we are only operating in city environments, but what if you have a route that does not only include city environments, but also rural areas, highway driving, and city environments within one overall route? And this is what you can see here. This is this 20-kilometer long track that we set ourselves as a challenge. And this was a huge ODD expansion for us. And some of the challenges that came up is these extremely large speed variations that you have along this route. Since we're talking about a deployment in Germany, as you all know, the speeds on a highway in Germany are actually not limited. So you have super high relative velocities that you have to deal with. You have to be able to drive at high speeds. We drove at up to 110 kph with our software stack fully autonomously on the highway. But at the same time, you have to be able to drive within these narrow urban streets of Munich. Next up, super complex traffic scenarios within the urban environments. And as we have such a large ODD, you have really also changing environments with construction sites changing all the time. And something maybe specifically to Germany, you have class-specific traffic rules that you have to embed somehow. So you have to deal differently with a cyclist as you have to deal with a car or a pedestrian. And we went back to the drawing board. We developed the algorithms to actually deal with these challenges. And I can proudly say our team and all of our PhD actually pulled it off. And something that I can show you here, this is the overall driving route, 40 minutes uncut driving of this 20-kilometer track. Since we don't have 40 minutes time, we sped it up a little bit for you. And what I wanted to, the point I want to make here is, even though the software is super advanced and we have come really, really far, there are still remaining challenges. So what are those challenges that are still remaining? And now you see some of them repeating. So what is still super challenging is maintaining the high map quality. As we're still talking about a modular approach, the HD map is super important. And this I will come back on later in my talk. Next up, also detection of rare object classes. We are not getting tired of this one. The data sets are getting ever larger and larger and larger, but you all know that catching the long tail is really, really tricky. Also, in our previous deployment, we were kind of operating in a closed loop environment. So we were basically driving at the same route all day long. But here we have an open loop scenario from the route perspective. However, we still encounter GNSS denied areas, especially within these narrow urban streets. And developing a super precise localization with centimeter accuracy and without drift, without relying on the ground truth from the GNSS is super challenging, and still I would say one of the biggest open problems also in the robotics community. Next up, if we have these complex city environments and also the on and offboarding, for example, on highways, you're talking about like cooperative driving. You have to somehow foresee the behavior of other traffic like participants and kind of like interact with them in a cooperative manner. And last but not least, if you have these ever larger increasing ODDs, you encounter more and more anomalies that we have to tackle. So with all of this in mind and with our software stack, and now with the capabilities actually to drive on a weekly basis, so our EDGAR vehicle is out there driving every week, collecting new data and collecting new anomalies and difficult scenarios. We said we were like sitting on a table, and I can remember like this day when we were sitting there and thinking about like what is the next challenge? What is the next big thing that we can do, that we can pull off, that we can also challenge our PhD with? And our idea was, can we actually bring this autonomous vehicle that we have seen here and that was able to manage this very difficult course to a new city, to a city that we have never seen before, to a driving route that we have never encountered? Is this possible with this modular driving stack? So this was the so-called Berlin challenge for us. We thought we will go to a new city, to an unseen environment, to a completely new traffic environment that we have never seen before. And can we drive there? Or at least like, what is the time, the upfront, the time that we need to drive within this environment? So the challenge here, unseen environment, different driving style, really intermodal traffic, and also varying traffic rules and traffic signs, in the sense that we have slightly different traffic lights and traffic signs in different regions of Germany. And this is actually very, very recent. Our team just came back from this Berlin challenge 2 weeks ago. And so this is the newest, latest research I can share with you. And also here, we were actually surprised by ourselves, like how transferable also this approach is. We were able to transfer this driving approach and this driving stack to a new, completely unseen environment within just 2 days. So what you can see here is a very short clip from this 6 kilometer long route in Berlin, where we're driving also fully autonomously with our Edgar vehicle. And now we are getting a little bit more in the nuances and in the last bits and pieces of the current state of the art of the frontiers of our field. So what are the remaining challenges here that we encountered? And one of them is that your overall system has to be somehow context aware in a sense that you have to understand what the people around you are doing. And this scene here is, I think, very descriptive for this. So you have like these kind of like parked vehicle or temporarily parked vehicles, but on the other hand side, you also have these vehicles queuing behind them, trying to overtake them. So you also constantly have to decide on, is this vehicle now stationary or just waiting to overtake? Can I safely overtake? And then also anticipate like the pedestrians around you. Is there someone now exiting this truck because he wants to offload some stuff and so on, and constantly adapting with this super challenging, with this typical modular approach where you don't have this context awareness, where you also only have like bounding box representations of the environment, but don't understand that he has the hazard lights on or the other guy is waving and so on. So this is a super tricky challenge to solve. Next up, this anticipatory driving style to prevent deadlock situations. So here, for example, with this bus, and we also know the situation from like established driving companies. So you have this bus and a few vehicles trying to overtake this bus, but then the bus leaving the bay, and you kind of have to brake to anticipate to this current situation, to not create a deadlock situation within this narrow environment here. And last but not least, HD mapping. As I said, we over the course of the years, we in our team, we developed a lot of different approaches actually to create high fidelity map data without even having to be on site. So we are able to create initial maps without ever having been there. But you still have to then constantly improve the map quality, adapt the maps once they are changing in real life. And this has to be done probably automatically to actually scale out to larger and larger ODDs. So with all of this said and with all of these learnings, I kind of wanted to end my talk with a call for action for the community with these remaining challenges, also as inspiring new ideas for the research field to actually take on, but also maybe some ideas on how can we approach these really challenging points. And we heard this already today by some of our great other speakers. I think one of the biggest leverage that we have as a community is actually democratizing our data sets, bringing all of this together to have like huge data collections to identify these edge cases to actually tackle the long tail, but not just the data sets, also open sourcing the driving functionalities to work on them together to really excel the development in autonomous driving. And something that I think has not been done on this level so far is actually federating map data. We all know like these really great initiatives like OpenStreetMaps, for example, but why not doing the same for HD map data to be able to go to ever increasing, ever larger ODDs, deploy different cities around the world. And this is something I wanted to give you as kind of an inspiring idea at the end of my talk. So if you are curious what will be our next challenge, please stay tuned and follow us, since all of the research that we do is always like challenge-driven and super interesting, and everything that we do is open sourced with the data, with the software stack, and also with our ideas that we share with the community. And with that said, thank you very much, and I'm looking forward to your questions.